open up and continue. Lesson 2. Dropbox, DIFC, workbook and slides, physics, mechanics, lecture 2. Oh, I probably should turn the TV on. Might be helpful. Hello. There we go. I still haven't figured out why it's putting that black line at the end. Oh well. Okay, if you write this down, scalars and vectors are our next lesson. Yeah, so just write this down, scalars and vectors. How was the homework last time? How did it go? Did you get them finished?
Yes.
Yeah? Yeah?
We finished them.
All of them? Oh, good. Okay. Right, so these are words I think some of you know already. So who knows exactly what a scalar is? You might remember it from high school. You remember it? Do you want to have a go? No? Okay. Anyone else?
We got SI unit.
Say again?
With SI unit.
It for sure has units, correct, but give me more.
Like mass.
These are examples, but what is a scalar?
No direction?
Yeah.
That's true, but you're not telling me what it is. You're telling me what it isn't, which is correct. It has no direction. What does it have? So you said it has units.
Magnitude.
It has a magnitude, yeah, that's it. So a scalar is a quantity that has only magnitude. Do you remember this word from last time? Magnitude means the size, how big. And no direction, as you say. For example, so you might actually know some examples. Someone said mass. Yeah. Do you know more examples? Volume, yeah, that's it, yeah. So here's an example. Walking at 1 step per second. That's a scalar. It's a scalar. However, if I said walking at 1 step per second to my home, that's not a scalar. There's a direction, yeah. Yeah. So anyways, for the exam, you would only need this much, okay? So you can write that down. Sometimes they ask for an example. It's a kind of a common exam question. What is a scalar? So it's something with only a magnitude and no direction. Yeah? Okay, continue? Yeah? What's the next thing I might do? Vectors, yes. So what is a vector then?
Quantity that has mass and direction.
Has magnitude and direction, yeah. So the example is walking at 1 step per second to my home is a vector. However, walking at 1 step per second is not a vector, it is a scalar. So again, for the exam, really, you just need this for the exam. Just one sentence. Yeah, it's okay for you over there? Yeah. So you switched from biology, science to here, and you are business. All right. So you looked at the biology class and said, "Not for me," and you looked at the business class and said, "No, thank you." Was that the idea?
Not exactly.
A little bit, maybe. All right, we have this. Continue. So, here are two examples of scalars and vectors, okay? Speed and velocity. Now, in normal English, a lot of people think of speed and velocity as the same thing, but there's a little bit of a difference. So, let's have a look exactly what speed is. So, speed, well, firstly, is speed a scalar or a scalar or a vector? What do we think speed is? It's a scalar, yeah. And speed is the rate of change of distance per time. So speed is distance per time. As an example, here's a speed, 50 kilometers per hour, or 10 meters per second. These are speeds. Or 1 step per second. What would be the formula for speed? Yeah. So they're all speeds. Mathematically, speed, the definition is distance travelled over time taken. So when you write this down, you don't need to write down the examples.
Just the formula.
In the exam, they're happy to take this or take this. But you see, if you know this, then you know how to write this as a sentence. Because distance travelled per unit time. Good. Now listen carefully to my question. What is the dimension? L over T, length per time. Yeah, LT minus 1 if that's what you're going for, yeah. And the units we would usually use? Meters per second. Yeah. Okay. Happy with that? Familiar, I hope, if you've seen it before. Yeah. Okay. Continue. You need a minute? It's okay? Yeah. Yep. So the next one is velocity. It's similar. Does anyone know the slight difference?
With direction.
Yeah, with direction. So how could we write it down? Velocity of an object is
The speed of.
Speed plus direction. Nah, let's go something else. I mean, that's true, but I'm going to go with this. Velocity of an object is the rate of change of its position, also called displacement. Position, displacement, same thing. Travelled per unit time. Your speed plus direction is fine, but I wanted to make the sentence have the same structure as the previous one. So I simply replaced the word distance travelled with position. Yeah. So let's have a look at some examples. For example, 50 kilometers per hour due north, or 10 meters per second to the finish line, or 1 step per second homebound, means to my home. They're all velocities. So as a formula, velocity equals change of displacement over time taken. And remember, displacement is just another word for position. So it takes me a while to remember names. George, I knew it was one of George, Matt, Kim, Simba, yeah? Close.
Remove the M.
I keep on it. Siba, okay. I forget your name. Andy? How could I forget now? And your name?
Ciao.
Oh.
Ciao.
Ciao, thank you. Much easier for me. Okay. You have this? Yep. Oh, by the way, did you check your Moodle? It's been changed to physics? Yeah. Your Moodle still says business. Does it?
I don't know.
Okay, no, we'll take care of it. We'll look at it later. Okay, continue? Yep. Alright, so, there'll be more definitions to follow. Okay, so precisely what is displacement? Because we've used it a couple of times now. Displacement is a vector. It's the position of an object at a point in time. So, for example, here's the displacement. The ship is now 2 kilometers to the east. That's a displacement. Or the man is 3 kilometers to the east of his home. They're displacements, okay? Because it tells you where something is compared to you. So, for example, he is 1 meter to my northeast. Well, I don't know, which way is north? That's south, isn't it? Huh?
I'm not sure.
Not sure.
The mountain range to the south. The school, yeah, north is this way. Yeah, so he is 1 meter to the southwest of me, southeast of me. Better. Okay, write this one down. So this is displacement. You got that? Yeah.
No.
No. Okay. Again, you don't really need the example. We use V to represent velocity. What do we use to represent displacement? What letter?
U.
Not U. S or X or. Those 3 letters. You could use an S, you can use an X, or you can use an OR to represent displacement. U is also for velocity as well. U and V are velocities. Okay, continue. Yep. So, terms like homebound and to the finish line, I mean, they're directions, but they're not very useful. So we need something a bit more precise. So often we represent vectors with a magnitude and an angle. And you can put this together on paper as an arrow. So basically we can represent a vector like an arrow. So the direction is represented by the angle where it points, and the magnitude is represented by the length. So the bigger the arrow, the more magnitude. And we call the top of the arrow the head, we call the bottom of the arrow the tail. So the length represents the magnitude, and where it is pointing represents the direction. So the vector pointing to him could be represented by an arrow. I draw the arrow from me to him and pointing to him. So like I'll draw a little picture with my paint. So here is me. Oh my goodness, what happened? They're all red. Okay, so that's that vector, you know, maybe this is northeast and this could be 1 meter, for example. Anyways, what I need you to do really is just to copy this picture in your notebook with the words magnitude, tail, head, direction. So Andy, what is it that you want to study next year?
Next year,
If you know.
I'm not sure yet.
Roughly, what were you thinking? Like what area of study?
Physics, actually.
Physics? Yeah, okay. So maybe some type of engineering? Or maybe, yeah. And what are you thinking of studying next year?
Computing psychology. It's like the robot machine.
Ah, like AI?
Yeah,
like
AI,
this.
yeah.
Good.
Yeah.
Do you know any programming languages?
No.
No, okay. So you have lots to learn.
Mm-hmm.
Good.
Yeah.
Okay, you have this? Yep. Alright. Okay. here's some questions. We'll do these ones together. So I want to draw the following. So are they all speeds or velocities? Velocities, yeah. So let's draw these together. So what I'll do is just mark off my north, south, east and west. Now I want a different colour. Let's go with green. So we'll say that's east, west, north. Probably made this too big. South. Okay, so the first one is 5 meters per second north. So that's vector A. And what's yeah, so I'll just represent it like this. This one is A. 5 meters per second north. Actually, do you know what? Before I continue, what you should do is you should write these down and then we'll draw them together. Okay? So just write them down and we'll draw later together. Yeah. So today's lesson is a little bit easier than the last lesson. A little bit easier. Okay, did you copy them down? Yeah, does everybody have this? Yep, okay. So the first one, are you all happy that it's 5 meters per second north? Now the next one is 4 meters per second east. So if this is 5, then a little bit shorter would represent 4. It should be 80% the length of 5 if you wanted 4. So if that represents 5, then 4 would represent like this much. But it's 4 to the east, so roughly that would be, I don't know, something like that. Okay. Alright. 5 meters per second west. So that should be the same as that one there. 1 meter per second south. So that could be represented by a vector like this. Okay. I'll just pause for a minute to let you copy these down before we continue. So far we have A, B, C and D done. Yeah, if you're using a ruler, that's nice. So maybe you want to make 1 centimeter represent 1 meter per second. If you want to. Okay, we're happy with that? Makes sense? Yeah. So let's have a look at the next one now. Right, now this is getting more interesting. at 3 meters per second, 30 north of east. 30 north of east. Do you know what that one means? How do I draw 30 north of east? Describe.
The
It's
angle,
30 degrees.
One sec, yeah, go on.
the angle,
Yeah,
30 degrees
Yeah.
from the east
in what direction?
to the north.
That's it, yeah. Were you going to say something similar? Yeah. So you start at the east, and you had 30 to the north. So, you know, something like this, where this here is 30 degrees. That's vector E. Okay. Next one. North 30 west. North 30 west. Who knows that one? No? Anyone know this one? North 30 west?
30 degrees north to the west.
60 degrees.
So where do I draw my 30? On the north line or the west line?
Then
Very good, yeah. So yeah, it's here where this is 30, and that's F. Okay. Now getting more interesting. Bearing 30 degrees.
It's clockwise.
Clockwise from... No, it's not actually clockwise. Sorry, no, it is clockwise. From where?
North.
From north. Yeah. So start at the north and go 30 degrees clockwise with the clock. That is G. And finally, 2 meters per second at 30 degrees.
to where?
This is a good question. What do I mean when I don't say anything? Yeah, so like, I mean, where do I draw this one? If I don't specify anything.
North?
Yeah, from the north? Nice try, because you're thinking it's like bearing, but it's actually not. Now, think mathematically. You know, where and how do you measure angles in math class? From what direction? Yeah.
To the right? From the west?
West to east.
Is it? I suppose if you're Arabic, it might be from the left to the right.
Okay, then
Here from the right to the left. So this last one here, 2 meters per second at 30, is just here. Because I mean, you know, in math class you have this circle, and you measure the angle around like that. Yeah? Tell me, in Arab countries, does it go this way around?
I think so.
Yeah, no, that would make sense because you,
From the opposite.
from the right to left.
Yeah.
But we still did it in English.
Yeah, but I don't know. Culture? I'm not sure. Like,
Yeah, we used to measure from the right to the...
if I ask you to draw a ladder on the side of a wall, do you draw this?
Yes.
Or do you draw this?
This.
Left or right?
I draw the right one.
You draw the one on the right?
Yeah,
Which one do you draw?
the right one.
Ah, okay. Would this not be the Arab way of doing it, no? Left to right? Yeah. Anyways, no matter. For us, when we just specify an angle, we just mean up from the anti-clockwise from the east. Yeah. Okay. Continue. No, actually, that was the only example. So I must have some really easy questions for you to do. Yeah. No problem. Let's see. Yeah. You'll get these done for sure. Only take you a couple of minutes. And then no homework for this lesson. So, on page 7 you have some vectors to practice. If you want, you can take a picture of this if you like. And here's the answers here. Yeah. You don't mind? You can share? It's okay? Yeah. If you don't get these finished, you need to take a picture so you can do them at home then, okay? Alright, you can start them now. Okay. Well, you can use that for now. I can close this? Yes?